In geometry, a transversal is a line that passes through two lines in the same plane at two distinct points. Transversals play a role in establishing whether two other lines in the Euclidean plane are parallel. The intersections of a transversal with two lines create various types of pairs of angles: consecutive interior angles, corresponding angles, and alternate angles. By Euclid's parallel postulate, if the two lines are parallel, consecutive interior angles are supplementary, corresponding angles are equal, and alternate angles are equal. Angles of a transversal: a transversal produces 8 angles, as shown in the graph at the above left, 4 with each of the two lines, namely I plus or minus, I squared, I cubed and I, and then I plus or minus 1, I squared 1, I cubed 1 and I 1. And 4 of which are interior, namely I plus or minus, I squared, I cubed 1 and I 1, and 4 of which are exterior, namely I plus or minus 1, I squared 1, I cubed and I. A transversal that cuts two parallel lines at right angles is called a perpendicular transversal. In this case, all 8 angles are right angles. When the lines are parallel, a case that is often considered, a transversal produces several congruent and several supplementary angles. Some of these angle pairs have specific names and are discussed below: corresponding angles, alternate angles, and consecutive angles. Corresponding angles equals. Corresponding angles are the 4 pairs of angles that have distinct vertex points, lie on the same side of the transversal, and one angle is interior and the other is exterior. Note: this follows directly from Euclid's parallel postulate. Further, if the angles of one pair are congruent, then the angles of each of the other pairs are also congruent. In our images with parallel lines, corresponding angle pairs are I plus or minus equals I plus or minus 1, I squared equals I squared 1, I cubed equals I cubed 1 and I equals I 1. Alternate angles equals. Alternate angles are the 4 pairs of angles that have distinct vertex points, lie on opposite sides of the transversal, and both angles are interior or both angles are exterior. Note: this follows directly from Euclid's parallel postulate. Further, if the angles of one pair are congruent, then the angles of each of the other pairs are also congruent. In our images with parallel lines, alternate angle pairs with both angles interior are I plus or minus equals I cubed 1, I squared equals I 1, and with both angles exterior are I cubed equals I plus or minus 1 and I equals I squared 1. Consecutive interior angles equals. Consecutive interior angles are the 2 pairs of angles that have distinct vertex points, lie on the same side of the transversal, and are both interior. By the definition of a straight line and the properties of vertical angles, if one pair is supplementary, the other pair is also supplementary. Other characteristics of transversals: if 3 lines in general position form a triangle are then cut by a transversal, the lengths of the 6 resulting segments satisfy Menelaus' theorem. Related theorems: Euclid's formulation of the parallel postulate may be stated in terms of a transversal. Specifically, if the interior angles on the same side of the transversal are less than 2 right angles, then lines must intersect. In fact, Euclid uses the same phrase in Greek that is usually translated as transversal. Euclid's proposition 27 states that if a transversal intersects 2 lines so that alternate interior angles are congruent, then the lines are parallel. Euclid proves this by contradiction: if the lines are not parallel, then they must intersect and a triangle is formed. Then one of the alternate angles is an exterior angle equal to the other angle, which is an opposite interior angle in the triangle. This contradicts proposition 16, which states that an exterior angle on a triangle is always greater than the opposite interior angles. Euclid's proposition 28 extends this result in 2 ways. First, if a transversal intersects 2 lines so that corresponding angles are congruent, then the lines are parallel. Second, if a transversal intersects 2 lines so that interior angles on the same side of the transversal are supplementary, then the lines are parallel. These follow from the previous proposition by applying the fact that opposite angles on intersecting lines equal and that adjacent angles on a line are supplementary. As noted by Proclus, Euclid gives only 3 of a possible 6 such criteria for parallel lines. Euclid's proposition 29 is a converse to the previous 2. First, if a transversal intersects 2 parallel lines, then the alternate interior angles are congruent. If not, then one is greater than the other, which implies its supplement is less than the supplement of the other angle. This implies that there are interior angles on the same side of the transversal which are less than 2 right angles, contradicting the 5th postulate. The proposition continues by stating that in a transversal of 2 parallel lines, corresponding angles are congruent and interior angles on the same side equal 2 right angles. These statements follow in the same way that Prop 28 follows from Prop 27. Euclid's proof makes essential use of 5th postulate, however modern treatments of geometry use Playfair's axiom instead. To prove proposition 29 assuming Playfair's axiom, let a transversal cross 2 parallel lines and suppose alternate interior angles are not equal. Draw a third line through the point where the transversal crosses the first line, but with angle equal to the angle the transversal makes with the second angle. This produces 2 different lines through a point both parallel to another line, contradicting the axiom. References: Holgate, Thomas Franklin. Elementary Geometry. Macmillan. Thomas Little Heath, T.L. The 13 Books of Euclid's Elements 1. The University Press, pages 307 ff.